In previous video, I talked about all these 9 topics. All the 9 topics I've been covered, and in this video, I'll be talking about direction, cosines, equation of line, symmetric form of line, equation of plane, distance of point from plane. So when you see this topic, it's little more complicated from the previous topic that I have thought. So moving into it, the first one is direction cosine. First one is now the main thing what we have to know in this direction cosine is L square plus M square plus N square equal to 1. So when we form this equation after getting the answer, we say the given vector, the given values of the directed cosines are being precise. Here the question is A equal to 2i minus 3j plus 6k. So computing it mod of, so we need to find the magnitude of A at the first. So root of 2 square minus 3 whole square plus 6 square equal to root of 2 4 plus 9 plus 36. So mod of A becomes root of 49, which is 7. So this is the magnitude value, and after finding the magnitude value we compute that L M N. So L equal to uh, taking the coefficient of I value 2 by 7, comma coefficient of j value 3 by 7, and coefficient of n value 6 by 7. So this is the direction cosine of the given vector, and then we need to check whether the given condition L square plus M square plus N square equal to 1. So L equal to 2 by 7 the whole square plus 3 by 7 the whole square plus 6 by 7 the whole square equal to 1. So it becomes 49 by 49. Hence 1. So we can this is the one of the important property of direction cosine. Now moving on to direction ratio. Direction ratio, it is actually found by difference of two vectors. Now given AB vectors, and the difference will become B minus A. Now for example, you take A as 1 2 3 and B as 4 comma 6 comma 8. So the difference becomes B minus A equal to 4 minus 1 comma 6 minus 2 comma 8 minus 3. It becomes 3 comma 4 comma 5. So this is the direction ratio of given two vectors. Moving on to next concept, it's equation of line. Equation of line is actually derived from r vector equal to a plus lambda b. This is the main equation of um, this equation of line. So given a point, in question, the main thing which will be specified is point equal to 1 comma 2 comma 3, and direction equal to 2 comma minus 1 comma 4. It's just a random variable which I have been put here, and computing this, a value is the point. Taking it as 1 comma 2 comma 3 plus lambda into 2 comma minus 1 comma 4. So we need to remember the which specified here is the point value, and B which is specified here is the direction. So R equal to 1 comma 2 comma 3 plus lambda into 2 comma minus 1 comma 1. So parametric form 1. So here the equation becomes R equal to 1 plus 2 lambda 1 plus 2 lambda comma 2 minus lambda comma 3 plus 4 lambda. So this is the equation of this is the parametric form. Symmetric and the next concept is symmetric form of line. This is actually continuation of this equation of line. So since we have got this equation of line in this form, in this form itself we form the symmetric form of line. Symmetric form of line, since we know this is this we take as x, this will take as y, and this will take as z. So here x minus 1 by 2, this is one equation, comma y minus 2 by minus 1, you put it into LHS, it becomes minus 1. Since it's in the multiplicative form, it comes below, and it becomes in this form. And next one is z minus 3 by 4, and these three are the symmetric form of line in this given question. So next, moving on to equation of plane. Equation of plane, which is n vector into r minus a vector equal to 0. So this is the formula of the equation of plane. This becomes little complicated because we need to know the n value and a value. So n value is the equation of plane passing through point. N is the equation of plane passing through point. Passing through point, and this a value is a normal vector. Now giving a random value for n and a. For n, I'm giving it as 2 comma minus 1 comma 1, and for a I am giving normal vector, I am giving it as 2 comma minus 1 comma 1. Sorry, in this I will be giving it as 1 comma 2 comma 3, and forming the equation, it becomes 1 comma 2 comma 3 into x minus 2 comma y minus x minus 1 comma y minus x minus 1 comma y minus 2 comma z minus 3. Here n value is 2 comma minus 1 comma 1, and this is the normal. Here a becomes 1 comma 2 comma 3, and normal vector becomes 2 comma minus 1 comma 1. Sorry for my previous explanation. This is the exact real thing. Normal vector is 2 comma minus 1 comma 1, and the equation of plane of product is a comma 1 comma 2, taking a as equation of plane product and normal vector as n. So computing these values, we get 2 into x minus 1 minus of since minus 1 minus of y into minus 2 plus 1 into z minus 3. Solving this we get 2x minus 2 minus y plus 2 plus z minus 3 equal to 0. 2x minus y plus z minus 3 equal to 0. 2x z minus 3 equal to 0. So this is the given equation of plane. In equation of plane, let me recap. This is the formula n into r minus a equal to 0. We need to know the n value and a value. A is the normal vector and n is the equation of plane. And this is the equation of plane. Yeah. Now n a is the normal is the n is the normal vector and a is the equation of plane. A is the equation of plane. N is the normal vector. A is the normal equation of plane and n is the normal vector. So moving on to the next topic, this distance of point from plane. So the given question, the find distance of point of 1 comma 2 comma 3. We need to find a distance of point from this plane from 2x minus y plus 2z minus 5 equal to 0. So here the formula here is d equal to mod of ax minus 1 plus b minus by1 plus cz1 plus d by root of a square plus b square plus c square. Here these are coefficient of these values are the abc values and this is the d value. Now equating in this equation, substituting in this equation a 2 and these are the xyz values. A is 2 into 1 plus b is minus 1 into 2 plus c is 2 into 3 minus 5 by root of root of root of 2 square minus 1 whole square plus 2 whole square. D value is 2 minus 2 plus 6 minus 5 by root of 4 plus 1 plus 4. Sorry. So here the value becomes 1 by root of 9 which is equal to 1 by 9. So this is the given distance of point from plane. From plane, this one from the given vector. So this is for in this video.